Hey everyone, so before we start actually finally study about organic molecules and the cell and the more interesting biochemical things that we want to study in the future for the admission exam, I want to make sure that we all have the same terminology when it comes to drawing and reading molecules from books and from different notebooks and lessons. And it's so important to understand that there are many different ways to draw a molecule, and it might be very overwhelming at first to see all the letters and stuff, but it's really easy. So I want to make sure to create this lesson to give you guys an opportunity to understand how to read and write to draw molecules yourself. So we are going to touch alkanes, alkenes, and alkynes. We didn't talk about them in the previous video, but in the previous video we were only talking about the alkanes. Just know in general that when you have a triple or double hydrocarbon bond inside, you have something called alkenes and alkynes. Just know for the general information, it's not something that we need to know right now. We will touch it when we actually studied in-depth organic chemistry. But right now, just remember, this is the names. Anyway, this is one way to draw a molecule, a hydrocarbon. So we have the 4 carbons, we draw butane this time. And we have hydrogens all around it, which is fine. We know how to draw it, we know how to read it. You can really see how many carbons you have and how many hydrogens you have. But there is another way to actually draw it, which is the more used way because it's very easy and fast to draw this molecule, and you need to get used to it from now. So when you have a hydrocarbon, you can draw it with the lines, and each line, each zigzag represents the amount of carbons we have. So butane can actually be drawn the following way: 1, 2, 3. And as you can see, this line, it looks weird, but what do we have right here? We have 4 corners. Each corner represents 1 carbon atom. So let me give you an example. This one, I will zoom in a bit so I will make sure that you see it. This one is 1 carbon. This one is another one. This one is the third one, and this one is the 4th one. Now the thing is that with hydrocarbon, that it is obvious when we don't have anything connected to the carbon. It means that the rest of the things that are connected to the carbons are hydrogen. If we had, for example, a molecule connected to it, I don't know, oxygen. If we draw it the following way and we would add the oxygen, we had to understand that the rest of the atoms that are not being shown are hydrogen, because for us it's supposed to be obvious that in organic environment, organic compounds, everything is just a lot of hydrogen everywhere. We have carbons and we have hydrogen. This is why we don't really need to say C, 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 and then to add all of our hydrogen atoms. It's a lot of time, it's time consuming, it doesn't make sense, and it should be very straightforward for you to understand that when we don't have anything, it's hydrogen, and when we have the corners in the zigzag line, it's carbon. If we want to add a molecule that is not carbon or hydrogen, we just add a line and we write down the molecule itself, the atom itself. So if I wanted to add another phosphorus, for example, I would just add a line and write phosphorus. If I want to add helium, for example, which doesn't make sense, but it's only for the sake of example, I would just do helium. Don't take this example as something that is an actual organic compound or something. It doesn't make sense. Just for the sake of example, this is how you would add different atoms that are not carbons or hydrogen. But what do we do when we have a double bond inside the hydrocarbon? So check this out. If I go for this molecule, for example, and I would want to write it down, so the first step would be to have 4 corners, 1 for each carbon. So 1, 2, 3, 4. but we have a double bond in the middle. So check out how easy it is to actually mention where the double bond is. All you need to do is to have a double bond inside the molecule. So now we have one carbon, second carbon, third carbon, and fourth carbon, and between the second and the third, we know that we have a double bond because this is how we represent it. Next example would be when we have a triple bond. So check out this molecule. We only have 2 carbons. And when we have 2 carbons, we draw it in the following way. We need 2 corners. So we need a single line. A single line which represents 1, 2 carbons. But now we need to show the triple bond. And as we did with the double bond, all we need to do is to add 1, 2 lines. So this is how you represent 2 carbons with triple bond. This is how you represent 4 carbon with double bond in the middle. And this is how you represent 4 carbons completely saturated. 1, 2, 3, 4. Just remember to count if you have a question on your admission exams. Remember always to count the amount of carbons you have. And remember to check which atoms are connected to this line, which are not carbons and hydrogens. And that's it. I only wanted to make this very quick lesson just to show you how we are used to write molecules in organic chemistry. In the future lessons, we are going to start drawing amino acids and fatty acids, and you would see that this way to write it down is crucial because we have to get used to it from day one, because everyone uses the following way. You won't see the following way to write down molecules unless it's inside textbook when they want to teach you how they actually look like. When it comes to organic chemistry and biochemistry, you would get the molecule in the following ways. Not in the following way, sorry. In the following abbreviation way. This. I hope this video made sense. If you need any help, please make sure to comment down below and to check our website EnterMedSchool.com, join our forums and like the video and subscribe and do everything that you have to do after watching a video. I will see you next time, guys.